Okay, good morning, everyone. In this session, we're going to discuss about the measures of central tendency, the mean, mode, and the median. So, we are going to discuss first what is mean. Mean is the arithmetic average of all the scores in the data set. So, this is the most frequently used measure of central tendency. And our mean has properties. One is the most reliable measure of central tendency. This is considered as uh, most reliable measure of central tendency because every score contributes for the computation of the mean. That's why this is the most reliable measure of central tendency. And another property is used when the data is interval or ratio. When we say our data is interval or ratio, we mean that we are dealing with numbers. So that is for uh, our data, which is either interval or ratio. A mean in layman's concept, this is the average. So for ordinary people, when we say average, most of the time they mean it as mean. And then all observations are considered in its computation. Next property is remarkably affected by extreme values. So our mean is affected most when there are extreme values. When we say extreme values, these are outliers. These are numbers that are too small or too big than the others. That is an example of extreme value. And then our mean is used when the data or when the distribution is normal or it is not badly skewed. So these are some of the properties of our mean. And mean, for sample mean, the we have here x bar, and this x bar represents our mean. So this is our symbol for sample mean, and another symbol for mean is the mu, which we will be dealing the mu uh, in the other lessons. So this time we'll be considering our sample mean, which is the x bar. The x bar, the formula for our mean is the summation of x divided by n. When we say summation, we mean that we have to add all the x. And then divided by n, the n represents the total number of pieces. So if there are 10 numbers to be added, so n is 10. So to get the mean, we have to divide the sum of the cases by the total number of cases. So in our example, if there are 10, so we divide the sum by 10. For example, find the mean of the numbers 5, 7, 9, 10, 12, and 15. So summation of x, we have to add 5, 7, 9, 10, 12, 15 divided by 6 because there are 6 numbers. So we have 1, 2, 3, 4, 5, 6. So divided by 6 because there are 6 numbers. And we have 58 divided 6 and the mean is 9.67. So this is how easy our mean is computed. The alternate formula for our mean for our ungrouped data is this one. X bar or mean is equal to AM plus summation of D divided by N, where AM is the assumed mean, and then D our D here is the deviation from the mean, and then N, the total number of cases. So when we say assumed mean, we are setting a value for our mean, assuming that it is our mean. So in this case, we have here values of Rx. So these are the values of Rx, and this is the deviation from the mean. So if we set our assumed mean as 6, 5 deviates a -1 from 6. That's why the deviation from the mean of 5 is -1. For 7 deviates from our assumed mean, which is 6, by 1. So we have here the deviation from the mean of 7 is 1. How about 9? 9 deviates from 6 by 3. And then we have 10 deviates from 6, then 12, that is 6, 15, that is 9. And then in our formula, we have to add all the d's. So adding the d, we have the summation of d is equal to 22. Therefore, we are going to plug in our formula, our assumed mean 6, and then the sum of these is equal to 22 divided by 6. So simplifying, we have simplifying 22 divided by 6, that is 3.67. Added this value to 6, we get mean equals 9.67. This was the value which we computed earlier. Okay, so this time we are going to discuss the concept of weighted mean. So what is a weighted mean? Weighted mean is just like a mean. However, a weighted mean came from a weighted values. So there are times that certain values has weight. For example, grade. Your grade has certain value. For example, calculus, the weight for calculus is 5 units. And then for Filipino, that is 3, statistics, 3 units, PE, 2 units, NSTP, that is 0 unit. So we have here the weights of our subjects. If ever we have grades, So these grades represent the individual score, which are the X. So for calculus, our grade is 1.5. For Filipino, we have 2.0. In statistics, 1.8. PE, 1.3. NSTP, 1.0. To compute the weighted mean, we have to multiply the X and then the W. So that is the formula for our mean is our weighted mean is the summation of X times W divided by the summation of W. So in this case, first we multiply 1.5 by 5. So this is already the 1.5 times 5. And then we multiply 2 by 3. And then so this is already 2.0 and 3. 1.8 times 3. 1.8 times 2. 1.0 times 0. Divided by the sum of W's. So we have 5, 3, 3, and 2. So we have to add 5, 3, 3, and 2. Simplifying, we have 21.5 divided by 13. and then 25, and then 21.5 divided 13, that is 1.65. Okay, another is the mean of group data. So there are two formulas that we can use in solving for the mean of our group data. So using midpoint method, this is our formula. Mean is equal to summation of f times x divided by n. And for division method, it is similar to the division method which we used earlier. The difference is that since this is already a group data, we are using frequency. And then, okay, so that is for group data. We are now using the frequency. And then the size of the class interval. So suppose we have our data here, theta 94, the frequency is 5, theta 89, its frequency is 7, for class interval 80 to 84, the frequency is 10, 75, 79, frequency is 15, 70 to 74, the frequency is 10, 65 to 69, the frequency is 5, 60 to 64, the frequency is 3. So first, if we use the midpoint method, we have to construct first the midpoint column. So we have here x sub n. How do we compute the midpoint? So we just add the lower limit and the upper limit divided by 2. So in this case, we have 60 plus 64, that is 124 divided by 2, and we get 62. For 65 to 69, we have to add them. 65 plus 69, that is 134 divided by 7, divided by 2, we get 67. If we know already the value of I, the size of the class interval, it's easy to construct the midpoint because all we have to do is to add the class size, going up 1. So we have to add 62 by 5, and that is 67, plus 5, that is 72, plus 5, that is 77, plus 5, that is 82, plus 5, 87. We have 87 plus 5, that is 92. After we constructed the midpoint column, we now multiply the f and the xn columns. So in this case, 5 times 92, that is 600 or 460. 7 times 87, we get 609. 10 times 82, we get 820. 15 times 77, we get 1,155. 10 times 72, that is 720. 5 times 65, it is 335. 3 times 62, we get 168. After that, we get the sum of fxm. So we get the sum. We have 4,285. Since we have already the value for summation of fxm, we can now plug in given in our formula. So as we computed earlier, the sum of fxm is 4,285 divided by n, which is 55. We get 77.91. So this is how our mean is computed using the midpoint method. Another method is the deviation method. So in the deviation method, as we said earlier, mean is equal to assumed mean plus summation of p divided by n times I. So we identify already the value of our I as 5, and then we are going to construct the D column. So we constructed here the D column, but how assumed mean is determined in the group data. So assumed mean, assuming that our mean can be found within 77 to within 75 to 79. So our assumed mean here is the midpoint of this class interval. So we have 75 plus 79, that is 154 divided by 2, and we get 77. So this is now our assumed mean. This is our assumed mean appear here, so the deviation from the mean is 0. Above it are 1, 2, 3, and below it are -1, -2, and -3. So this is how D is constructed. After that, we multiply F and D column. So 5 times 3, that is 15. 7 times 2 equals 14. 10 times 1, that is 10, and so on. After we constructed the FD column, we have to add the values in our FD. So in this case, summation of FD is 10. And then we can now plug in the given in our formula. So mean is 77, so we have here 77 plus FD, summation of FD is 10 divided by n, which is 55 times 5. Simplify, we have 77 plus 0.91, and that is 77.91. It's also the value which we got. Now we compute our mean using the midpoint method. So this is the two ways on computing the mean. By means of division method, and another one is by means of midpoint method. Okay, so this is now another measure of central tendency, which is called the median. Median is the middlemost score in the distribution. It divides the distribution into upper 50 and lower 50. And these are the characteristics of our median. First, middlemost score or observation in an array. Median is not affected by extreme values. Median is not amenable to algebraic manipulation. When the distribution is closely asymmetrical or skewed, median is the most appropriate measure of central tendency to use. This is also used in an open-ended distribution, and this is used when the data is ordinal. So these are the characteristics and properties of our median. To find the position of our median, so we can use n plus 1 divided by 2 as our formula. For example, find the median of the following scores. We have 4, 6, 2, 8, 7, 8, 9, 9, 3, and 5. Before we can identify the position of our median, it is necessary for us to arrange the scores either in ascending or descending order. So here, I already arranged the scores in ascending order, and then all I have to do is to count the sixth position, because there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So there are 11. There are 11 cases plus 1. We have 12 divided by 2. That is 6. So I am looking for the sixth position. The sixth position is 7. Therefore, the median is 7. So this is how easy our median is computed. Another example, we have 4, 16, 13, 2, 40, 35, 19, and 25, and 40. Again, before we can find the position of the median, we have to arrange our scores either in ascending or descending order. So in this case, by arranging our scores, we have 10, 13, 16, 19, 20, 25, 35, 40, and 40. Position for median is 10 plus 1 divided by 2, that is 11 divided by 2, and it gives us 5.5. So the position of our median is 5.5. That means the median is located between the fifth and the sixth scores. So we have to add the fifth and the sixth score and then divided by 2. So in this case, our median is 19 plus 20 divided by 2, and that gives us 19.5. So this is finding the median of our scores when there are even number of cases. And this is the median of the group data. So for the median of group data, so we will be using this formula. Median is equal to LD. LD represents the lower boundary plus n over 2 minus cumulative frequency before the median class divided by the frequency of the median class times I, the size of class interval. So we have here our class interval. This is the same data as we used when we are computing the median and the mean. Okay, in our formula, there is a cumulative frequency. Therefore, in our table, we have to construct our cumulative frequency column. How cumulative frequency column is constructed? Whatever the value here in F will be reflected in our cumulative frequency column. So here we have 3, so we write 3. And then we add 3 to 5, or we add 5 to 3, and we get 8. So 8 plus 10, we get 18. 18 plus 15, that is 33, plus 10, that is 43, plus 7, that is 50, plus 5, and that is 55. So this is how we construct our cumulative frequency column. After we constructed our cumulative frequency column, we are now ready to identify the frequency of the median class and then the frequency of, or the cumulative frequency before the median class. Before we can identify the median class, we have to compute the n over 2. So we now compute the n over 2 so that we can identify our median class. So what is n over 2? For n over 2 is equal to 55 divided by 2. And 55 divided by 2 is equal to 27. We have 27.5. We are going to locate the 27.5 in our cumulative frequency column. So 27.5 belongs to class interval 75 to 79 because if we consider 18, 18 is less than 27.5. Therefore, we move in the upper class interval. So in this case, this is 33. That means our median class belongs to cumulative frequency 33, in which the class interval is 75 to 79. And then the lower boundary of 75, so we just subtract 0.5 to our lower limit, and that becomes 74.5. The highlight row is already our median class. Therefore, the frequency of our median class is 15. And then the cumulative frequency before the median class is 18. With this information, we can now plug in the given in our formula. So we have here our lower boundary, that is 74.5. 55 divided by 2 minus 18 divided by 15 times 5. That gives us 3.17. Added to 74.5. It will give us 77.67. So this is now our median of our distribution. Okay. The next is the mode. Mode is the most frequent score appearing in the distribution. Mode reflects the most typical value. It is located at the peak of the distribution. It is not unduly affected by extreme scores. That means mode can be affected but may not be affected by the extreme values. This is very unstable value and most appropriate when the data is nominal. So for example, if we have our numbers 3, 4, 6, 7, 7, 7, 8, 8, 9, and 10, the mode is 7 because the most score appearing in the distribution is 0. So in case there is only one node, the distribution is called unimodal. And then if there are two nodes in the distribution is called bimodal. Then if there are three, the distribution is called trimodal. And if there are four or more, our distribution is called polymodal or multimodal. Okay, here in letter B, so we have our our scores 10, 9, 15, 10, 8, 11, 7, 12, 11, 20, 11, 5, and 10. The modes are 11 and 10. So we have 10 and 11. So these are the modes because they appear twice in our distribution. This distribution is called bimodal. It's easy to determine the mode of ungroup data because it can be determined using inspection. Okay, next, mode of group data. In computing the mode of group data, so this is the formula that we are going to use. So we have mode, MO, is equal to the lower boundary plus, this is the lower boundary of the modal class, and then we have FMO, frequency of the modal class minus frequency before the modal class divided by twice the frequency of the modal class minus frequency of frequency before the modal class minus frequency after the modal class. Okay, so this is the very first thing to do in computing the mode of group data is to determine the modal class. How can we determine the modal class? The definition mode is the most appearing square in the distribution. So in this case, we are going to look for the class interval in which the frequency is the highest. In this case, the highest among the frequencies is 15. Therefore, the highlighted row is the modal class. So 15 so 25 to 59 is our modal class. So this is now 15 is the frequency of our modal class. F1 is equal to 10. So this is the frequency before the modal class. And then 10 is the frequency after the modal class. And we can now substitute in our formula. Okay, so the lower boundary, we have 74.5. 74.5 was determined using 75. This 75 represents the lower limit of this modal class. And to get the lower boundary of this class interval, we are going to base it from our lower limit, which is 75 minus 0.5, and we get 75.5. As we determined earlier, the modal class is equal to 15 minus the frequency before the modal class, which is 10, divided by uh, twice the frequency of the modal class, which is 15 minus 10 minus 10 times 5. Simplifying mode is equal to 77. So this is the comparison of mean, median, and mode. How person developed this formula? Mean minus mode is equal to 3 times mean minus median. If we are going to compute the mode is equal to thrice the median minus twice the mean. For example, the mean and median distribution is 12 and 15 respectively. It's the mode of the distribution. So using this formula, you can now plug in the given median and mean values to get the mode. So in this case, our mode is 1v1. To learn more about our lesson about measures of central tendency, you can refer to our handouts. And for now, this will be our topic. Thank you, everybody, and goodbye.